morning, friends. Today we are going to discuss innovation in the Indian context. That too, a public sector organization. There is an inspiring story from the ICF. So we will learn this today. As an engineer, our role is to find a solution to problems faced by society using technology. See, it's very, even though obvious, very not very well known. Generally, for a medical practitioner, yes, his role is to cure the patient, to make them healthy again when somebody falls sick. But engineer, what is that equivalent role? So, as an engineer, we are supposed to find solutions to the problems in the society using technology. So that is equivalent of a engineer's role in a society. So as engineers, to come to the level of solving the problems, we need to learn. Our learning should not stop at the reading and remembering stage. We should be to a level of applying our knowledge to solve day-to-day problems. This is the main intention of this learning. So, as engineers, we should not stop at the remembering and reproducing. That kind of low-level learning is not sufficient. We have to understand it, apply to solve the day-to-day problems of the society. So, at the higher level, even we have to learn to create the things. So, the design thinking is the methodology by which we can scientifically solve the problems of the society. Okay, every engineer should learn this technique. To solve a problem, first you have to understand the problem. So, how to know what are the problems faced by a particular society setup? So, first you have to empathize with them. Means you have to understand the problem. Think like customer. Suppose what are the problems faced by a bus traveler? You have to travel in a bus like the customer and try to first hand find what are the problems. So that is not one day. It can be extended to few days and morning, night, evening. So that you will get full spectrum of the problems what they are facing. So once you collect the data first hand, empathize with them and think like customer, then the second step will be analyze this problem. Analyze. There are many tools. One of the simplest tool is YY. So this YY tool is first came into prominence in a Japanese industry. Toyota industry has popularized this to solve the industrial problem, but it can be applied to any situation. So once the analysis phase is done, the third phase will be solution. So you have to think and use scientific methods to have a solution. But solution normally will not be in a single step. Solution involves iterative steps. The solution has to be tried with the real customers, and iterative means you have to take care of many odd conditions, various different situations. This should work. So solution will normally be iterative process. Once the solution was arrived, so the next step will be to test this, to test the solution with the real customers. Okay. So to remember these 4 steps, if you put all the first steps, empathize, analyze, then solution and test, we call it a yeast. So in this class, we will learn a success story of a innovation in India, very much relevant to us, and that is happened in a public sector called ICF. So the picture shows two type of trains. One looks modern and one looks very old. So we have these trains more than 100 years in India, but always we are producing same type of trains, even though technology has improved and a lot of innovative things are coming in the field, and even the world over a lot of advancement has happened, but we keep producing same kind of trains. So as an engineer, the person shown in the picture is basically a thinker, a design thinker. So he is worried about why we are not changing according to the modern devices, modern tools, modern needs. So his name is Sri Sudhanshu Mani. He is an employee, ex-employee. He retired now. He is worked in railways, so integral coach factory. So he always wondered why we produce same kind of coaches last 50 years and without improvement or innovation. So this problem is going on his mind for so many years. Finally, he got a chance to try out something. He became head of that institution. So what he has thought is he first traveled along with his team with the real passengers and found out what are all the customer wants to change this train to more human good experience. So innovation is he realized that innovation is very important for to survive. So if you see the world over, there are Fortune 500 companies in the world. 30 years some companies were there. Now 30 years to now, if you see 88% of companies which are Fortune 500 30 years ago not there. So only 12% remained out of this 500. New companies came into that slot. So 500 companies of 30 years old and now only 12% were remained in the top 500. Many of them became bankrupt, many of them closed down, or they simply the turnover is less than suitable for Fortune 500. So they moved out of the list. So many innovative companies came into the Fortune 500 like Google, Apple, all this came into the Fortune 500 in the last 30 years, even Amazon. So technology is always disruptive. So we have to be disruptive to be progressive. So this is the existing engine, state of the art engine in India. This engine is capable of delivering 6350 horsepower, 6350 horsepower, and it can draw some 40-50 coaches behind. So the problem with this is it has reached saturation. You will not be able to increase the size of this engine any further. If you have to increase, the dimensions will go up. So you cannot increase the width because the railway has a fixed broad gauge system. If you increase the width, it will foul with the coming trains coming in the opposite direction. Similarly, it has to pass under many bridges, so height cannot be also increased. Only length a bit can increase. So it has reached saturation. So he studied many of the engines in the world, and he came to conclusion that if you concentrate all the engine features in one engine, then there is a limitation. But if you break this and shift into many coaches, then you have unlimited power you can put into this engine. So he, with this idea, he has developed the new trains. So he analyzed first he traveled with the people, empathize with the cause, and then he found out what are all the new features this train should have. So he has the basic data. Now he has come to the industry setup. Why ICF or the IS stuck up with the same kind of production, no change? So he found some of the reasons are bureaucratic. So he found in the ICF, the engines were dealt by a different division and the bogies were a different division. Suppose if he makes engine and bogie equal, so means engine will be there on each of the bogies, that is a composite train, which department will make and which department will own the thing. So bureaucratic hurdles. So when he became chief, he demolished those bureaucratic bottlenecks. He created a new organization suitable for it. There is no engines division, there is no bogies division. So all the people and different teams has worked on the combined thing. Next is he found second reason why the ICF is not innovating is the government machinery and the bureaucrat generally risk averse. They don't want to take risk and take the stick from agencies like CAG and other things. So they want to prefer continuation of the existing. So they don't want to take the risk. So he took nearly fought with the people nearly 2 years to try this new idea. So what he wanted is around 100 crore. Normally a new train costs 100 crores. But he is innovating and doing things. There is no royalty. He is doing from fundamentals. So he is confident of making one full engine in 50 crores. So he requested ministry to sanction resource for two trains. Each 50 crores. So two trains, all that's all he want to make. And he told ministry, give me chance for making two trains. If he fails, they can rest of the money, resource and all, they can import also. So finally he could convince the ministry. So he has now all the resources at hand. Ministry has approved his two trains to be manufactured in ICF, try out his things. And he has the eligible team, he has the basic inputs on what to innovate. Now, because of this bureaucratic hurdles and all, some valuable time is lost. Finally, when the approval came, he has just 18 months to make this train. Since his scheduled retirement is in 2018 December, so he has to complete this during his tenure. The team has told if he retires and some new person can come, his priorities could be different. So they told that this train they will try to make in 18 months instead of usual 2 to 3 years normally. Otherwise, this kind of innovation takes world over. So his team work out day and night to complete in 18 months. To every day to remember this fact that it has to be complete in 18 months, the project was named as Train 18. That's why the name was Train 18. So they actually they could do this in 15 months. That is 3 months clear ahead of the schedule, and they before his retirement, these trains were given permission to test run. The trains were already, it has to be passing the test runs. So 3 months ahead they could complete. So what are the innovative features this team has thought out and innovated? So the earlier one loco train, that is one engine is there, it is pulling all the bogies. So because of that, the engine capacity could not be increased beyond 6350 horsepower. Now he's broken down the engine. There is the power is put in all the trains, all the coaches, all the split. The power was split. Since train is electric, but instead of a single big engines of 6350, they are split into 250 horsepower, 250 kilowatt, not horsepower, 250 kilowatt motors on four corners of each coach. So each coach is having now 1000 kilowatt. So number of coaches have number of, so each coach is 1000. Suppose you want a 10,000 horsepower, you can couple 10 such bogies, then the train is capable of having 10,000 kilowatt. That is enormous power. So some of the features he has, innovative features were listed in the slide. Earlier what is happening is the power is not concentrated in a single engine, it is distributed. So the second advantage people got is the train engine, when it reaches the destination, it has to disconnect from the main train. The engine has to come all the way, turn 180 degrees, come back, come to the extreme and backside and get connected and to take it back that journey. So every trip it is wasting 15 to 20 minutes of valuable time minimum. Sometimes takes even half an hour. So this train don't have this reversal problem. It can pull in both the directions because all the coaches has the engine. This is in a way engineless train. This is popularly known as engineless train. Means that not that it is engine is not there. There is no separate engine. Engine is there in all the coaches. So drive is in all the coaches. So there is no reversal requirement. 30 minutes straight away in each trip they saved. These one big engine is hauling some 20 or 30 coaches. Acceleration is very sluggish. But, now this with this split with the engine and lightweight engines where the coaches were made, the acceleration is really quick. It is reaching very quickly. It is able to accelerate from station to station. Earlier, we have many coaches. Out of 16 coaches, one is wasted for the engine itself. So, considerable platform length is wasted for a small stations. The platform length is not sufficient with the engine and another 16, 17 coaches. Since there is no separate engine, that much length of the platform is saved. Then there is the weight is distributed. And earlier the engine is pulling nearly 16 coaches. So the huge size of coupling it has to be there between the engine and the coaches. So a lot of power it has to transmit. So coupling size is bigger. So now since it is every coach has the engine, so the coupling size has become smaller and it has become lightweight. The transmission itself has become weight will be very less now. Then since become it lightweight, the acceleration is better and there are no jerks. And since we have 16 coaches, each has the engine, so there is a redundancy. Earlier, one train is having one engine. Suppose that engine is damaged or comes under repair, whole train stops for few hours till another help is coming from the nearby central station to pull this engine train. Another engine is coming. Now even since all the bogies has the engine, even one or two bogies are non-functional, till like normal it can pull on. In fact, actually only 50% of the bogies are engine is powered, rest are idle. So they can they run any time but waiting. So redundancy is excellent in this train. Now, whether they achieved the target, yes. During the testing phase, earlier the target, the maximum that could achieve, including Sadabdi Expresses, they could achieve only 130 kilometers per hour. Now these trains are running very high during trial runs. It has reached a speed of 150 mph, that is more than 200 kilometers per hour during the test phase. Of course, the track has to be suitable for this train. So India has certain stretches which is has a suitable track to handle more than 180 kmph, and in some stretches it's suitable for 200 kilometers per hour. And the acceleration is very high. Quick acceleration ability of 0.7 meters per 0.7 meters per centimeter square is the acceleration achieved. Next, these first two trains were constructed like chair car type, means only seats, there is no berths in this. So they were mainly for a daytime journey of something like 6 hours, say Delhi to Varanasi and back. So now two trains were operating of this type. One is from Delhi to Varanasi and the second train is from Delhi to Katra, that is in the Jammu Kashmir region. These trains during their empathize phase, they found lot of people are traveling like in families, so many close people, so they are not even able to face each other to talk. So he innovated this feature of rotatable seats. These seats, Compared to earlier train what we are traveling, these are very good. It is like a aircraft flight like situation, very good seats. He innovated this train seats in such a way that train seats are rotatable to face the people behind. Six people can face each other. A family of six people traveling can actually face each other by this rotating mounted and a rotational base. And this train was made up of earlier it is a very thick carbon steel rolled sheet. It is made up of stainless steel which will not rust. And because of he is migrated to stainless steel which won't rust, so there is no requirement of providing a corrosional ones. So instead of 2 or 1.6 thickness, he could use the only 0.6 thickness of the coach outer. So the weight of the coach has come down drastically. Then what he has done, he has connected all these trains, vestibules to connect all the coaches, and doors are automatic. And also in some platforms there is a height difference between the coach and the platform. He has provided automatic footsteps. When the train stops and doors opens, the footsteps will open onto the platform. People can comfortably walk onto the platform. Next innovation during the empathize phase, he found toilets are unhygienic and not user friendly. So he has introduced a toilet called bio vacuum toilets. These are used in flights. So when the earlier trains were moving, when somebody uses the toilet, the defecation is coming between the tracks. All the entire track is made unhygienic and smelly. So even the platforms in a big railway stations were smelly because of some people used when the train is parked in the station. So these trains have was bio toilets where there is no thing coming out. The biodegradation of the defecated thing will be happen inside the toilet, and only weekly once or something the residue will be collected using a when the train comes for a service, that will be collected, that biodigested solids or whatever what is residue, and it can be sold as a fertilizer. And the next innovative feature he has done is a regenerative braking. So it saves power. Whenever train comes or braking applied, the motors will act like a generators, pump the power back to the grid. So a lot of power is saved on the brake. No wastage of power during the braking. So he is used bipolar transistors, IGBT type insulated transistors. There is one more innovative features. This is the thing how it looks like. See how modern and aerodynamic the train shape is. And you see so many windows. The train is passing through a picturesque surroundings like Madhya Pradesh and all. People will have a lot of window space to see outside what is. So people like that ride. So it is tremendous happiness for the people traveling by these trains. So I once traveled by this train, and you have to travel by this train to see the experience. So he has put all the modern amenities, like there is each seat is provided with a audio visual entertainment system like flights, and there is a GPS. You can listen music and you can watch your favorite movie or a TV program. And also there are plug loads, like there is a small pantry in each of the coaches, and as I explained earlier, there is a rotatable seats to face each other. So there are a lot of innovative features were incorporated in this train. It is no less than any trains, contemporary trains in German or US. And this was done indigenously. Most of the components were indigenous to the extent of more than 80%. And it was done at half the cost. Now there is an export market for this. These are the seats. You see, seats were mounted. You see the seats facing each other. Earlier in one picture, you say all the seats were facing the one direction. Now you see the picture. seats were rotated to face each other. And driver cabin, you see like a flight like appearance, all the controls at one place, and air conditioned. Could see complete picture of the. It is no less than a flight cockpit. So full AC, and the drivers are so much automated. They will be their kind of a signal system. Even somebody by accidentally jumps a signal, train stops automatically. So train will stop, or there will not be any power in the next section if the clearance is not there. So train automatically comes to a stop. So much made life easy for the drivers. So let us learn as engineers some of the important technical innovative features of this train, how they modified from the existing single engine with so many coaches to the power is distributed out to all the coaches. For it is these trains will have normally 16 coaches, 4 set of it. So there are 4 sets. Each 4 coaches is one set. So the coach set was named. First one is DTC, indicating it is a driver cabin. Okay, but driver cabin does not mean passengers won't sit. Only first 1/8 of the portion of the train is meant for driver and other controls. Rest 7/8 portion is meant for passenger sitting. So this driver coach as well have passengers. The second coach is motor coach, where the actual motors of 250 kilowatt is mounted on all 4 corners of the coach. So each MC coach will have 250 kilowatt into 4. That is 1000 kilowatt of power on each MC coach. Then the third coach is TC, is a traction coach. TC coach is actually having, see in electrical systems, power is not supplied like our domestic thing at 230 volts, and not even at 450 volts. It will be supplied at very high voltage, rather than 11 kV, 22 kV. So in some places it is 25,000 kV or 32,000 volts. So normally it is 22 kV. Why it is in 22 kV? Because for transmitting power over a long distance, the losses has to be minimized. If it is low, see, since the power into the voltage into current is equal to power, if you have to have low current, then voltage is very high. So to have low losses, losses, I square R losses, the losses of transmission is resistive losses like I square R is proportional to square of current. So to have less losses, we should have I as low as possible. So V as high as possible. So voltage generally chosen voltage is 22 kV or even higher. So for this, these trains are supplied with a overhead power of 22 kV. Now, so the power from the train overhead line has to be picked up using a device called pantograph. So these pantographs and the transformer, why transformer is required? But power is picked up 22 kV. The power has to be converted to lower voltage to feed to the motors. So those motors were running at 415 volts, the 250 kilowatt motor. So from 22,000 volts to 415 volts, the transformer and the pantograph and other things were mounted in this coach DC. But that does not mean this coach is fully occupied with this equipment. It is mounted on the rooftop. Below, as usual, passengers will be sitting. They won't know what is happening on the rooftop. So passengers will be sitting full on the coach. Only top portion is used for pantograph, transformer, and some other equipment will be beneath the seats of the passengers. Passengers won't be knowing at all. Then once again the motor coach. So this 4 makes a full complete train. If the only few passengers are there, they can use this first 4 coaches. But more passengers to be carried, this has to be replicated in 4 multiples of 4. If you see, the second 4 coaches were MC, TC, MC. The last coach is you find the name NDTC, means there is no driver. See, driver is not required to be sitting in all the 4 coaches. The first coach and the last coach, it is kept, that is sufficient. So in between those coaches, or there is no driver coach, it is like usual coach with full of the passengers. So those are called NDTC coaches. So from the 16 coaches were optimally utilized like this. So what are the equipment each coach contains? DTC is a driver coach, means a portion of the coach is sitting, driver is sitting, rest of the portion passenger sitting, but beneath the passenger sitting, the bottom portion of it is loaded with battery charger, such things. The good point of this train innovation is, in the power overhead power goes off also, train of course will not move, but passenger amenities like pantry car, entertainment system, Wi-Fi, all things will work on the battery. So even air conditioner will work. That much battery capacity is mounted in these coaches in the bottom of the passenger seats. So those coaches were packed with a lot of power. So 6 hours it can sustain, even some power loss is there. Passenger comforts, there is no problem. Then the MC coach, as I explained earlier, it is on the overhead, the traction converter and brake chopper, resistor, and the traction motors, these kind of things. MC coach will have the motors, mainly the traction motors are there, brake chopper and traction converters are there. The above passengers will be sitting. All these were located in the bottom portion, so that center of gravity is nearer to the earth, near to the ground. Then TC coach, traction coach, on the top of it we have the traction pantograph and the transformers. Then MC coach, MC, and once again it is MC coach out of 4. First is the driver coach, DTC, second is MC, third is traction coach, 4 is MC. Traction coaches, the 4 have one traction coach. Actually, in the entire 16 coach train, only 2 TCs are sufficient to take the power and operate. But the balance 2 TC coaches were waiting idle. Whenever an emergency occurs, one of the TC is not working, they will raise the pantograph and operate. So there is a 100% backup for TCs. So even when TC coach, the pantograph or transformer gives problem, train won't stop. It will continue its journey by raising the pantograph on the coach on the second and third modules or fourth module. So only 2 TC coaches for the entire 16 coaches is sufficient. So that much reserve is built. Now check how much power is there. Out of the 4, there are 2 MC coaches for each 4 coach system. So out of 16 coaches, there are total 18 such MC coaches. So each MC coach has 250 kilowatt powered 4 wheels. So this 250 into 4, for each coach is having 1000 kilowatt power. So out of the entire 16 coaches, if you operate 8, then 8000 kilowatt power is, that is tremendous amount of power. If you calculate 8000 kilowatt, it will be 10,000 horsepower plus. So a lot of power. So you will be able to accelerate this train to 200 mph if required, provided track is suitable. So this is the arrangement. The middle coaches will have no driver coach. This entire train arrangement like this. This is what I am talking about, the pantograph. These traction coaches on the top of it will have pantograph. It is basically a device to access the power on the rooftop overhead lines. The hydraulic action you can lift and lower. For which of the coaches you are collecting power, those pantographs only lifted up and slowly touched that overhead line with a switch gear. For other 2 pantographs will be down and resting idle. Whenever required, they can be raised. So these are some of the technical parameters. What is the wheel size and other things. So what is the load each wheel can take, and as engineers we want to know more technical details. So what is the efficiency of this gears and all that. The data is provided for our just understanding and appreciation. So any electrical system will have one single diagram. Even it is important not only for electrical engineers, any engineers will try to understand what are all the electrical devices have in this train. They are grouped in one single sheet. That's a single diagram. Everything is put into a single paper. So entire electrical system were explained in a single system with a single diagram. For any system, single diagram is very important concept, and people will ask first, what is the single diagram? To understand the electrical systems of anything, be it a train or a power plant, single line diagram is a very important concept. So in the single diagram, you will see what are the transformers, what are the traction equipment, what are the lighting, what are the battery applications. So everything is what are these wattages and volts, what is the step downs. Everything is put in a single base to give the understanding to the people what are all the systems in this train. So to conclude, we have an Indian situational thing to inspire the people for innovate. So this innovation happened right in front of us in the last 2-3 years, right from 2016-17. So daily exciting news is coming from ICF, and all engineers and scientists in the industry were excited about the it is happening in India. So they followed this design principles of empathize, understand, analyze, solution phase and testing phase. They are successful. They did it fast. They did scientifically. There are no hiccups in the trains once it is launched. So it's a perfect case of understanding a design thinking in a practical way. So I have a lot of fun, enjoyed making this video. So you too, I hope you have a lot of understanding and appreciate the fact that this happened right in India, and a lot of these features were came out of this design thinking. So it is a very perfect lecture for understanding the design concepts and design thinking. Thank you very much. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.